Today on the NASO video and podcast, we're joined by Margaret Schotte with her new book, Sailing School, Navigating Science and Skill, 1550 to 1800. The North American Society for Oceanic History was created by maritime scholars who met in 1971 at the University of Maine. They recognized that in North America there was no forum for maritime history or a society devoted to the study and promotion of maritime history. The aim of the original group of organizers was to create a diverse organization based initially on Canadian and American membership, which would gain the interest of others. Now there are members worldwide, and it is this diversity of membership that continues to make NASO a truly unique organization. 2020 marked the first year in recent memory that NASO was unable to meet, and therefore we bring historians, archaeologists, and students who are scheduled to present. Welcome to the North American Society for Oceanic History video podcast. I'm your host, Sal Mercogliano. The goal of the NASO podcast is to bring you some of the best historians, professionals, and up-and-comers in the field of maritime history. Today we're heading to Toronto, Canada, and being joined by Margaret Schotte. She's the author of the new book, Sailing School, Navigating Science and Skill, 1500 to 1800, and the winner of the 2019 John Lyman Book Prize in the category of Naval and Science and Technology. Margaret is an associate professor of history at York University. Welcome, Margaret, to the NASO video and podcast.
Thanks, Al. Happy to be here.
I'm ecstatic to have you here, and as we were talking about just before the video began, I was a former merchant mariner, and so I absolutely just devoured the book, enjoyed it immensely. And the reason I'm holding this book up here is I brought props today, is I actually brought my books from when I was a maritime navigator. So I have my Bowditch, which is what you call this. This is the American Practical Navigator, my Bowditch. And I both back in the day when there was volume 1 and volume 2.
Oof,
and all of mine are marked up and edited like crazy with formulas and tables. And so I just, again, I went to school not thinking I'd ever need math when I went to college. Sat through high school like I'll never use trigonometry, and then became last ship I sailed on. I was navigator, and all I did was trig. That's all I did. So
I should ask you: did you use like certain instruments instead of the trig, or you were like, no, I'm doing the math because the math gets me more accurate answers?
Well, the funny story, and again, there's a great lead into this. So I graduated, and hate to give away my age, but I graduated in 1989. Yeah. And when we were doing celestial and terrestrial navigation, I remember my celestial teacher telling us now that, you need to know this for your license exam, but you'll never use this because electronics is coming out and we're going to have these satellite navigations, and you'll never do it. And the very first ship I sailed on, as soon as we got down in the Caribbean, we're down in the Caribbean after Hurricane Hugo had come through, and all our electronics went out. We had no electronics whatsoever, and we couldn't get it repairs, couldn't get anything. And so all we did was celestial and terrestrial navigation. And we didn't have, the great calculators like you have today with portable computers with you. So we were doing the trig, we were doing the, we were grabbing sun lines, moon lines, you name it. We were just, and it really actually made me a better navigator, because after that, I never relied on electronics when I could take a chance and get a sun line and do a evening star shoot. So what you talked about in this book, and again, let's get to you, not about me, this is about you, is how navigation developed during this period of time from 1550 to 1800. And I thought it was an amazing foray. You use a couple of historical examples. You go through a series of kind of vignette historical examples to talk about this. And I want to get your background. Why pick this topic? It's such a unique topic to really delve into, and we'll get into the details of it in a minute. But why this topic for your research?
Well, a couple different answers. One is I have maritime family on both sides. My dad from the Netherlands and grew up right on the river, the Rotte River, and loved boats. So we always would go and like tour the harbor. And Rotterdam Harbor is, one of the most important and largest in the world. So there was definitely sort of a love of boats from the beginning. And then my mom is from the Maritimes in Canada, so Nova Scotia, and I spent a lot of time there. And I tried, learned to sail when I was a kid, and forgot a lot of it. But the thing about learning to sail in Nova Scotia is the weather's not always great. So often we would be doing our, week of sailing camp, and it was entirely on land because it was too foggy to go out. So we tied a lot of knots. So anyways, so those are the sort of personal side of why I love this stuff. And then I was working for a rare book dealer, and we sold a lot of illustrated books and like really beautiful travel narratives or architecture or whatever. But we also sold some history of science books. And the thing was, they only sold if they had interesting engravings. Like if they had cool diagrams, that was easy to sell. And there was a whole little section of poor, ignored, left behind math textbooks. And I was like, wait, I think these math textbooks have a story. And then as I was applying to go to grad school, I was like, I think they have a story, but I'm not sure I want to spend 5 to 10 to however many years working on math textbooks. But could I combine sort of the navigation side, the love of sailing, with the book history? And it turns out that these navigation textbooks have a lot of the same stories, right? You kind of can hear who was the author. Well, odds were that he was, running a school and wanted to sell some stuff, right? Or maybe he'd invented an instrument. He thought he could get his students to buy it. So anyways, I kind of took the book history angle into navigation. So those are the two sides of my story.
I think I want to talk about the book for a second here, because I think Johns Hopkins is the publisher of your book, and they do a fantastic job of illustrating this book. I have to say that one of the things that makes the book really appealing is the images that are included in it, both within the text and then the color section in the center, which is just fantastic. I mean, I think the illustrations really bring alive a lot of what you're talking about. I know we talk about pictures worth 1,000 words, but in truth, you really need to understand those images. And I think, with this book without those illustrations would be still a great book, but I think it just makes this so much better. So really kudos to Johns Hopkins for putting together.
The funny thing is that, in the 17th century, like here are these guys who are trying to get their books on the market and trying to sell them. And, and the publishers had the same bias, like, no, illustrations are expensive. They take up extra paper. We don't have money for illustrations. So I sort of felt, sympathy with my authors, because it's really hard to get a press to pay for images. And so luckily, Johns Hopkins was like, yes, this book couldn't make sense. And it really wouldn't appeal to as wide an audience if I couldn't explain things, right? And you need the diagrams, or you need to see, when I talk about volvels, well, those are little spinning discs. If you can't look at a spinning disc, then you don't know what I'm talking about. So I really think, as you say, it wouldn't be as accessible as a story if you couldn't kind of take a look at the manuscript pages as I'm analyzing them. So, and huge thanks actually to my university archivist who, when he found out what I was working on, was like, well, we need to buy a manuscript for you, So there's this amazing Dutch manuscript from 1705 that is now at home here at York University's special collections. And those are the end leaves. And again, I'm like, if you put the image of this manuscript, and it's all these mathematical calculations, probably similar to the trig you were doing, but if they were in the page, they would just be tiny, right? But the fact that they can be on the end leaves of the book, I have my book here too, but like you can open it up and, hold on. And then at least you can see kind of the whole notebook page, right? And you can zoom in and say, hey, that guy's handwriting is kind of, legible, or look at his diagrams, or oops, he made a mistake. So anyways, I'm kind of grateful to have that extra space to just show what it was like to be, computing all those.
It is so funny you say that, because like the end leaves of my copies of Bowditch are the same exact way. I mean, I have sample formulas in there, and I remember doing my tests as like, okay, I need an example. Let me put my examples in here. And this is back when I was a student learning how to be a navigator. Yeah. And that's the thesis of your book, really. You're talking about training of navigators, and you're talking about a very unique profession that again, I think you bring together this idea that navigators are these highly skilled technicians. They're not, you know, the picture, the stereotypical image we have of sailors. They're much more than that. And I was wondering if you could talk about that, how that goes about, and understanding. Obviously, there's a need for these highly skilled navigators as the world becomes a much smaller place, as we're doing circumnavigations of the globe and much longer transits than before. But in how they go about this training, because you also talk about, and we'll talk about this in a little bit, the dichotomy, the difference between the training on the ships versus on land. So let's talk about them as highly skilled technicians first.
Well, so the interesting thing is there's this big shift in the 16th century of, you used to have a lot of coastal trade routes. You used to just be kind of repeating the same voyages. So people would have the technical information in their memory. And when things started to be transoceanic, the sort of open water, blue water sailing, all of a sudden you're in a place you haven't been before. Your memory is not, you know, going to help you with geography the same way. And one of the arguments of the book is that actually your memory now can be deployed to help you with math. But especially in the 16th century, when a lot of pilots or navigators were not yet literate, you know, how do you teach them? And in Spain, they were like, you know what, we're going to just bring them into a classroom and start lecturing at them. And, you know, we have these old textbooks from universities. It was a completely illogical way to start training these pilots, pilotos. But, you know, other European nations were like, hey, the Spanish, you know, the Iberians, like the Portuguese, they're up on this. We want to copy them. So that same kind of university training model gets exported. And so we start to see the Dutch doing it, and the English and the French. Everyone is sort of gathering their navigators into a classroom. And that's when you can kind of teach them the definitions or help them work through the mathematics. And so it didn't used to be a requirement that navigators be literate, but really by the 17th century, if you weren't, you were not going to climb up the ladder as quickly. And you needed to be able to pass an exam. And so then you start to find people are going to teach you the material you need to know on the exam. So there's a lot of early teaching to the test, which is kind of interesting. And one question I get is sometimes, you know, aren't we just talking about one navigator per boat and there are hundreds of other sailors? And so you're really just the tip of the iceberg and it's not really a really important group. Well, one thing that I really believe is that they were training extra people, right? Because you don't know what's going to happen to your navigator. Is he going to get scurvy? Is he going to die? Like there could be all these tragedies, and then your boat is going to be out of luck if you don't have anyone else who can run some numbers. So there's this sort of descriptions in various books about how everyone's gathering around the binnacle at noon to take their observations. And then you compare, right? And so usually it's the chief navigator's observations that, you know, are the ones that the boat is going to, you know, follow that day. But other people are allowed to, you know, voice their opinions and what did they get. And, you know, they talk about, you can't just have two observations because how do you know which one's right? So you actually need three. So there's all this kind of group learning. And I think that's one of the ways that a lot of like the pilot's mate would be learning, even though he's not in a position of power yet, he's kind of in the pipeline. And, you know, maybe a few years down the road, he'll be able to be a pilot himself. So anyways, it's this whole kind of training program to build up the mathematical abilities of a lot of people on the boat. So I don't know. I hope that gets to your skilled technician question.
No. I think it's great. I mean, because you really caught, I mean, again, you know, it is a great read, the book. And in your introduction, when you talked about this imagery right here, you know, talking about the navigators watching the crew moving tobacco, but the navigators are kind of hands off and you know, you start creating that kind of hierarchy within a ship structure in some ways. I mean, you always had the captain as being that hierarchy, but now you have those officers underneath them, and the skill of the navigator for being, as you said, a vital commodity is as important to the ship as the hull and the sails and the cargo it carries. Because if you can't get from point A to point B, and especially in a proficient amount of time, you're going to lose potentially money and everything. And I was also interested in your concept of it being transnational. This isn't just, nationalities creating that, this is information that's being shared across, which creates kind of I hate to use a terrible phrase, but brotherhood or sisterhood of the sea type stuff, where mariners are going to share this type of information. I don't know, you could talk a little bit about that and how this goes across, because the 5 examples you use in the book are across different nationalities. We're talking Spaniards, Dutch, English in these cases.
Right. So when I started this project, I was really thinking, like, I'd like to figure out how people invented instruments, who gets credit and what happens with these different instruments. And did they try and keep them secret? Is there something about, like, this instrument is our country's and we're not sharing? So I go to the archives and I'm like, all right, find me the secret files on the French Navy. Find me, the espionage. Well, it's pretty hard to find evidence of secrecy, right? It's that kind of problem. And a lot of these inventions were actually anonymous, right? You're not going to get like, oh, we know so-and-so's quadrant. And like in 2 or 3 cases, you have the name of an individual and an instrument associated. So I had to change course. I had to say, like, that project is not going to work, because people, if they did invent something they wanted to keep secret, it didn't end up in the archives. So that flip side became the story, that actually there's a lot more sharing of information, because you'll find people writing about to say, well, the Dutch use this instrument and the English use that one. We, the French, are going to try and use the English one. And so there's a really interesting and important book about the 16th century Spanish world, which is called Secret Science. And Maria Portuondo says, at that point, cosmography and navigation were closely guarded by the Spanish crown. But by the late 16th century, that picture has changed completely, because as soon as you have print, then things get shared across, they get smuggled, they get reprinted. The Dutch market is so happy to have, maps that they can engrave and sell. They translate their atlases into English, into French. They're like, hey, let's sell more books. Let's try and get these, there's a market share we can be part of. And so it's interesting to see that, like, print is actually one of the things that helps spread this information, even though so much of that information was previously kind of, that memory information that you would think harder to share, that kind of tacit knowledge. But actually with print, it gets codified and then sort of spread in a very standardized way. And that's, again, one of my arguments, that the French, the English, the Dutch are all copying that Spanish example. And that's why we can start to make interesting comparisons of, well, when we see the French do something different, what does that mean? That means they have a particular problem that is different from what the Dutch are doing, and they solve it in a different way. But they were all starting from the same sort of point of origin. So.
And I think the publication of textual textbooks and manuals like this really puts on end the concept that all Gutenberg is printing are Bibles. It really, okay, the Bible's a hard thing to print. It's really big. It's really long. It takes a long time and it's really expensive. But here's something that we can put together that has practical applications that people can begin to purchase and buy. And now all of a sudden it can be out there. And I was really taken by you had a quote in here from Martin Cortez in 1551 that he set the tone for navigational textbooks for years to come. So I was wondering if you can introduce him and explain why he's such a important person in really setting the tone for everything you have coming after that.
Yeah. Actually, I'm giving a talk in a couple of weeks on, like, the book market and selling nautical manuals. And Cortez and Pedro de Medina are the 2 Spanish examples that I'm going to start with. And what's really interesting is their textbooks are oversized, they're illustrated, they are expensive, and they are clearly kind of aiming not at just the guys who are going to sea. They're probably also aiming at, gentlemen merchants and maybe princes, so they're just trying to sell their book. And then that information gets reprinted and condensed into smaller and smaller formats, more and more affordable. But it's sort of the way that the Spanish approach the problem is that kind of old university knowledge that I mentioned. And actually it's this kind of cosmography, so like geography, but it's the science of the heavens. And these are old books, Appianus, Sacrobosco, and they were sort of initially in the university curriculum to think about, like, where are we in the universe? What does it mean to be a human on this little planet? And that's what they thought that the pilots needed to know. And so those textbooks start with what's the equator? What is a pole? Like, what's the zenith? What's the ecliptic? So they're really starting with the kind of technical information, which would have been really unfamiliar to, again, semi-literate navigators. But you need those concepts if you're going to be out on the open water, and you have to look up and understand why you're taking certain angles, why you're, shooting the sun, why you're keeping track of the different constellations. So that cosmography model is really what goes into textbooks, and at least, 75 to 100 years, you can see people following that Cortez pattern. He has a chapter on the winds, a chapter on the tides, a chapter on, tries to explain why. I feel like, why the year has 365 days, like all of that is in his textbook. Some of that drops out, right? Because it doesn't actually matter to a navigator why the year has 365 days. And then that's when we start to see English textbooks shift away from that. And instead they teach people arithmetic. So we used to have the first chapter be about definitions. By the 1680s, these textbooks are starting with addition, subtraction, multiplication, and division. The Dutch don't need that because their navigators probably took a math class before they went to sea. When they were younger, they had already kind of done their arithmetic, because it's sort of a more merchant-based society. There's just a lot more numeracy happening. And so those textbooks start with the tides, and they're interested in trying to tell you, you can't sail out of Dutch harbors if you don't know exactly when high tide is happening. Like, if you are off, by an hour, you're going to strand your boat on a sandbar. So for them, we need to start with the calendar. What day of the moon is it? And what month in the kind of 4-year cycle? And with that information, you can then compute what time your particular harbor is going to have high tide. So anyways, we start to see these different sort of variations in textbooks on national lines. No, I think that's the quick version.
but I think it's so appropriate, because again, I keep flipping back to my experience, and again, if I pull up a copy of Bowditch today, 35 years after I did it, it's a much different book. It's a 1-volume book. A lot of the introduction material isn't there that was there. I mean, there's a section in here on how to use a calculator, which I found very funny, when you go back and look at it. But I think you're right. I think as you look at that evolution, and it's kind of geared to what's the audience and who it is. If it's a Dutch audience, like you said, they're probably a little bit more educated than maybe a Spanish crew would be.
The French are like these poor farmer boys that get, pulled out to sea. They haven't had to read or do any math, so they're in. But so I'm glad you have the picture of Bowditch, and this Bowditch illustration's not in the book, but it's kind of the end point. I kind of take us up to the 19th century as a way of understanding, like, why did this information get codified in this way, right? Why is navigation taught this way? And so there's a tricky dance, because again, some people look at textbooks like they're not innovative. They're kind of old-fashioned. They don't move. They don't evolve in the same way that other kind of books do. And so that's what's so interesting, that you have these Dutch books that are, almost verbatim for more than a century. And then within that, when you start to see changes, that's, again, what I think is cool. But this Bowditch here, so 1802, and I think this is the Massachusetts edition. So here we are, basically taking a British text and updating it. improving it, right? The improved practical navigator. He's like, sorry, old British guy, I'm going to make yours better, make mine better than yours. And then, as you said, it's filled with tables. But look here, this, frontispiece facing the title page is of the solar system. Where are we in the heavens? Why do the heavenly bodies move in a certain way? How do we do our observations? So that is a throwback to Cortez and Medina and the cosmographical kind of orientation. You can't think about sailing across a curved surface underneath the curved heavens unless you kind of can understand the solar system. So I was totally tickled to find that, 250 years after they were teaching sailors about the solar system, 1802, they still want people to understand that. So
I joke with my students all the time. Before I even get to that, I do not know anyone who's gone through a maritime education who do not keep their books from like the navigation. No one keeps their history book, unfortunately. No one keeps their English textbook from the class. That's long gone. But everyone I know who ever sailed has got their books from the professional education on a shelf somewhere, and it's a very treasured possession for them because they will always have them.
Exactly my argument. Like, you used to need to memorize geography, right? And then when we start printing atlases, you don't need to have that in your memory. You can just consult, the atlas on your shelf. And so similarly, a lot of these textbooks are filled with like multiple ways of solving one problem. There's like a geometrical way, trigonometric, use an instrument, and if all else fails, like here's how to estimate it with your hands. Like there are lots of backup methods. And I keep asking, like, do we see multiple methods in math books? Are there other textbooks where we have the same kind of concern that you can solve something several different ways? And I think there's something about, you're out at sea, and if you lose your backstaff, like you still need to be able to get your ship to safety. So I like to see these as like extra attention to risk management. And then I really think people use them as references. They might not have honestly read every chapter. Maybe they just needed to read the chapters they needed to pass the test. But if you were in a tough situation, you knew you had it on your shelf, you could go and say, there's something in that book about, if it's been foggy for a week and I can't take a noon sight, then let's see, what else can I do? And so you sort of have outsourced your memory into print, and you keep it there, and you use your working memory for other pressing things.
Well, and it goes to the practical application, which is one of the other issues you talked about, which I think is really important too, because getting a site, for example, is dependent on so many factors. I mean, the weather factors, the clouds, and everything. I can remember, taking a moon line, which is one of the toughest sites ever to do because it's the fastest moving object, and you always tried to do the lower limb of the moon, but if you couldn't get it, you had to get an upper limb, and there was different ways to factor that in. And I can remember going back to my books, like, okay, I got it. I don't remember how to do it. But I captured it. I got the time. I got the angle. Now I got to go figure it out. And so that. I'm having 35-year-old flashbacks right now,
awesome.
back to school. But I want to talk about this practical application too, because I think that's such an important element too. Is it's not just on the deck plate, so to speak, on the deck learning, but also setting up these kind of maritime academies, these kind of hands-on school. You joked about making a knot. To this day, I could tie a bowline behind my back. And it's the most useless feature trick I can do, but it's from doing it over and over again, and it kind of ingrains in you. I was wondering if you could talk about that, because I love this image of the mock-up ship in the courtyard.
And so people have actually researched this ship because it survived for a really long time. So this is the Dutch training academy in Amsterdam Harbor, right in the center of the city. But it's a later innovation. It starts in 1785. And so what's kind of striking is they didn't need a state-funded central academy until that point, because I think if you wanted to get a job, you went to night school on your own time. You went to summer school, or winter really, probably. So these Dutch mariners were already paying for private lessons. But when they get to this the kind of tail end of the 18th century, and the Dutch East India Company is on the wane, and there's really a lot of concern to make sure that people are absolutely crossing T's and dotting I's. And so you actually see the Dutch kind of, I would say, foundering under the weight of all their regulations. But I think people have really looked to this training academy because it's got this hands-on component. So here I've tried to count how many people are in the rigging of this this ship, and then up on the roof there is sort of a platform where you can take observations. There's like an armillary sphere up there, so they probably were really taking sights on top of the building, easier than on the boat. But so this is a really interesting way of how do you test someone with like actual practical skills. When you look at the records of the English exams, they ask people, okay, so tie a knot for me, future lieutenant, tie, you know, let's see, what would you do? What would you do with the rigging? And it's a bit of a question. Were they doing this on dry land? Was there a boat moored nearby when they were taking their tests and they kind of like pointed to it? Or were they doing it with a small model, like just one of the, you know, I don't know, however many feet long models, which they definitely did have at the Royal Mathematical School. You know, is there anything comparable if you're tying tiny little knots on a tiny little model? Well, clearly this particular ship would be a better idea. And so people around the world really look to this Dutch, you know, model of learning on board a ship as superior. So then the French were like, well, we have always admired what the Dutch do. Let's come up with our own training ships. And so there was a proposal to tie a ship in the Seine, like right in downtown Paris. Like, again, not sure that that's really going to, you know, like give you the sense of how to, you know, you're not going to get your sea legs on a ship that's moored in the Seine. So then there are a couple other examples of these little boats plying the coast. And what do? Everyone's, you know, vomiting, they're sick, then they get some other kind of pleurisy, and then, you know, there was a big problem of trying to get your green recruits seaworthy. And the other thing that comes up in the evidence is, if there is a war, you don't want green recruits on your military ships because they're going to get you killed. So what do? And if it's peacetime, you're not going to have very many ships sailing. And so it's really a problem. How do you actually give people sea time without, you know, putting the whole operation at risk? So Napoleon did not think that you could do this kind of training. You shouldn't have, you know, like, careful, keep your green mariners off the boats. So
I think it's an interesting comparison today to like simulators and a lot of things that are used in maritime field today to train, which is really good. I mean, there's some fantastic simulators that allow you ship control and ship handling, and again, you just miss out on that one aspect of a ship rocking back and forth, the spray in your face, trying to get a sight, you know, which can only be done when you're out in the middle of the ocean, or like you said, you know, get green the first time you get seasick. And
the other thing that's kind of interesting, there are these records of like different teachers, and they really did. The Royal Navy hired a lot of guys to teach onboard ship, and the problem is you only find complaints, right? You're like, this guy's too serious. He's like making us sit here for too many hours, and so you're like, well, that particular teacher might have not been the best, you know, pedagogically, but like maybe some of the other guys that don't find their way into the records were actually quite effective, you know. Like you're only going to find the kind of squeaky wheels that are unhappy, but these other teachers that, you know, are kind of gone from our memories, they might have actually been, okay, we're going to teach you a little math today, and we're going to do, you know, a few sites tomorrow, and then if the weather's good, we're going to, you know, give you the day off, and then if the weather's bad, then you're going to work some observations for me, you know. So I think some of that happened, and it's hard for us to recover it. But.
No, I think you're exactly right. I mean, my college experience was at State University of New York Maritime College, and in a 4-year college, and you know, we did the classroom experience, and then every summer we took our school's training ship out for 2 months. Awesome. And I can remember, you know, being bored to death in the classroom and like this is terrible. But when you got out on the ship and all of a sudden you had to practically experience it, it was a much different aspect. I liked my teachers on the ship much more than my teachers in the classroom. I'm sure my teachers love hearing this now, but it's I think you get that practical experience, and you know, you're seeing how what you're learning is being applied directly, which I think is a unique thing in the maritime training aspect.
Right.
Your book is structured so you have a series of chapters, and you jump around. You start in Seville in 1552, you go to Amsterdam in 1600, Dieppe 1675, London 1683, and the Netherlands in 1710. I don't want to go through all of them, but I want to go to the end, because I think your last chapter is a really interesting one, because the chapter is entitled Lieutenant Rios is Put to the Test in the Southern Indian Ocean 1789, which I think is a great culmination of everything. And I wonder if you can talk about who Lieutenant Rios is and what happens to him as a kind of venue to talk about everything in the book.
Yeah. So talking about like kind of archival serendipity, I turned my dissertation in April, or the last week of March. And then April, I fly to England. I'm going to a conference at Greenwich. I'm like super excited. This is awesome.
Center of the world, Greenwich, England.
I know, right?
That's always the center of the world.
Right. So I give my talk, which is on like the Spanish school system, and, you know, and then I've got extra time. So I'm like, I'm going to go to the archives, because I'm right here in the same building at, you know, the Royal Maritime Museum, National Maritime Museum, Royal Museums, Greenwich. And so into the Caird Library I go. And I'm like, well, I was here a few years ago. Let me see what else I didn't get in that first pass of their kind of relevant manuscript material that's both like navigation, but also mathematical. So I call up some things, and I find this whole set of documents by this Edward Rieu. And he is this lieutenant, but there's a lot of interesting stuff. And what I have kind of realized about him, he must have been super meticulous and like a really great record keeper. There's actually a letter from him to his mother. It says, "I've misplaced one of my important nautical workbooks. Can you please save it if you find it, because it's got very important information?" Well, lo and behold, it's in the collection at the Caird. And it's not filled with very important information. It's filled with his doodles. It's filled with like his complaints about how tedious it is to be, stranded off the coast of Newfoundland in the November fog. But his mother saved it. And then ultimately, after his death, all of his materials end up at the archives. And so that's why I actually have records of this young naval officer and the trigonometry homework he did when he was 14 years old. So he was from this family where his brothers went to the Army, but he was going to go to the Navy. And so he had what I think was probably private tutors at home. He does these beautiful, kind of perspectival views of ships, and he works through these math questions, saves it all. Then he gets to sail around the world with Captain Cook. Then he, again, spent some time off of the coast of Newfoundland, but he's twiddling his thumbs. There's not really a great posting for him. And then he's asked to be the captain of the second ship taking supplies to Botany Bay in Australia. And so there's been one transport with convicts, and they send those guys off to Australia. And then they realize, we're setting up this new penal colony. We need to supply it. So Rieu, you're in charge. And the Royal Society, Joseph Banks, kind of outfits the ship with a certain select number of livestock, rabbits, deer, cattle, sheep, and then also builds a little greenhouse on the deck. And in that greenhouse, there's like a whole sort of set of interesting and important plants that the British think that they should introduce to the Australian outback. And then supplies like hats and shoes and salt beef and wine, all this stuff. So this boat is like laden with things. There's only 24 convicts on this boat. And this is 1789. Rieu heads south from England, puts in at Cape Town, and basically gets fresh water. This is December, and the goal is to head south to Botany Bay / Sydney. So we don't know exactly what happens. We don't know why, but within a few weeks of leaving port, they're low on water. And I don't know if it's that the livestock was drinking too much or what, but Rieu notices this iceberg And he's like, oh, well, I remember Captain Cook, when he saw an iceberg, went and harvested floating chunks of ice. Let's try that. So Sal, the next time you're in the Southern Indian Ocean and short of water, guess what? I don't know, drink ale, but like, don't go after the iceberg, the floating ice chunks, not a good idea. So anyways, they get too close to the iceberg and a huge chunk of it, hives off and staves in the stern, takes out the rudder. And so Ryu swings into action. And this is kind of remarkable because we have blow by blow record of what he does. And he divides people into two groups and he says, pump, we've got 5 pumps. One's not very good. Okay, so we've got 4 pumps. The pumps keep breaking. Don't worry, you guys have got this. Meanwhile, people are actually like leaping off the boat, getting drunk and just abandoning ship. It's Christmas Eve. It's got to be cold. Like, it's just, horrendous, right? And so as many people as can get into the ship's boats. Most of them are not seen again, but one of these boats does make it and is rescued by a passing French vessel. So, of course, Ryu stayed with the ship, right? He kind of gives this impassioned speech about how he's going to, oversee the Guardian, keep her afloat. And so then the master is on the smaller boat that had been rescued, and he sends a report to the papers in London to say, well, Edward Ryu has gone down with the Guardian, it's very sad. That, I think it was April that things got published, right? So this accident happened in December. It just took that long for the word to get back to the press. 4 days later, a new letter arrives in London and gets printed and says, hey, the Guardian didn't go down. Edward Ryu and the whole ship made it back to South Africa. And so basically there was 2 months where he was, keeping this crippled ship as close to on course as he could. He was going back to his reference library to try and make sure. He was pouring through where had Cook been? Is he going to hit Madagascar? Because he doesn't know much about Madagascar. I mean, he's got one guy on board who had rounded the Cape before. And so they're really hoping that they end up somewhere that they can manage. And fortunately, the ship must have just drifted, or, it wasn't drifting, but, just made it west enough that they missed the really treacherous water at the Cape. And end up back in Table Bay almost 2 months after they had this huge accident. So
it's an amazing story. It's why
right?
I wanted you to share it. And to me, it really put together a lot of the subject matter you were talking about, which I thought was just a great encapsulation. Right.
And so I just sort of think, like, if I hadn't gone to that conference, I wouldn't have found this material. I wouldn't have this piece that's like just such a perfect example of like a guy who did a lot of math and then had actual practical experience and then couldn't have gotten out of this problem without both of those things. So, and thank goodness he wanted his mom to keep all of his records.
Well, again, all mariners love their mother, so it's like a universal.
They don't all love math, but
no, they usually don't. I want to ask this one last question, and that's regarding the research on this. Okay. Your bibliography is amazing. I mean, it's an extensive bibliography and research. I was wondering if you could talk a little bit about that, how you handled that. What were some challenges, obviously, in doing this? You're doing multiple languages across the board. Right. What were some of the biggest hurdles you had in doing the research for this?
So what's really interesting is I started this research in 2007, and a huge amount of things have been digitized in that 13 years, but really mostly in the last 5 years or less. Right? So if I wanted to have evidence of what these early Dutch textbooks were, those weren't digitized in 2007 or 8 or 9. So I would go to the archives and just take thousands of pictures, right, of all these textbooks. And I have to confess that I skipped a lot of the tables. Like, I'm not taking pictures. Well, how can the tables be different? And now I'm like, I wonder, actually it'd be really interesting to compare these early Dutch textbooks, how their trig tables differ from the ones in the, English textbooks. So I just brought, like, it was the kind of huge like, I don't know, finding mission, like what's out there, what kind of manuscripts are interesting, what counts when you call up, if you go, to the military archives in Paris, what are you going to find? And because I did this huge survey, I started to find these similarities, and they're like, wait, I've seen these same diagrams, these sort of like circles where they're trying to find, the declination of the sun. Here, this is a French manuscript, but I'm sure I've seen these in Dutch manuscripts. And so that's what helped me come up with the story. And that was where it was really like, the similarities are remarkable, and you wouldn't necessarily have expected that. You have to, if you think about how so much maritime history is pretty nationally focused, like the Brits want to focus on the Royal Navy, the French are really, really thorough about the French Navy and its captains and its training, but they don't compare it to how, what the Dutch were doing at the same time. And I was like, this is the angle, actually, to say all these people are tackling the same problem. And I wouldn't have realized that if I hadn't just gone into every archive and called up everything that had to do with navigation. So it was a very long and big project, but really, I think, satisfying. So
no, and like I said, I think it brings up a universality too of how commerce and navigation is universal. Even though we get so fixated in mercantilism and this empire building of these individual nations, this aspect of it really crosses those national lines, which I thought was a very salient point, because these mariners have got to learn how to overcome new challenges and deal with, transoceanic voyages and multi-oceanic voyages, not just one ocean, but multiple oceans, and what they can learn from each other and what they can cull from each other to get a leap over them and continually kind of go back and forth, which is, very much business and economics today in the maritime industry.
Right. And I mean, the cool thing is that, there are similar examples of these manuscripts in Germany, and I think also in the US, right? I've spent a little time at the John Carter Brown Library, but also other archives in Rhode Island. There are really similar manuscripts. And I think hopefully, the kind of argument I make in the book applies to these other locations too, right? We can say, this is not, starting with tradition and going to like modern, amazing mathematical prowess. Like the argument is, people really had mathematical knowledge at the beginning, and they keep tradition at the end, right? So instead of seeing it as like this, arc, great kind of historians are, reacting against, Whig history, right? We don't want to just say this is a narrative of progress. This is a narrative of, it was actually really complex and impressive at the beginning, and it continues in different ways, but, let's keep both parts at play here. This is really hybrid technical knowledge the whole way through.
No, and I think for a historian, you also give good warning. You can run down a rabbit hole here, and you focused on English, Spanish, and Dutch in a very finite period of time. You're still spanning several centuries here, but this could turn into something huge and massive and literally unmanageable. But I think you did a great job of putting that together into a very readable format and interesting. When I have to teach a course and in a survey course, and I got to teach the scientific revolution, I can use the examples of the textbook, which they use 10,000 different times in the past. But I like to, bring up, James Cook and use the Cook voyages to talk about scientific revolution, because it's a different application. Here's a physical application of the scientific revolution. Let's look at how he uses all this in there. And that's what I got from your book. I enjoyed it immensely.
Thanks so much, Sal.
I want to thank our guest, Margaret Schotte, for joining us for our NASO video podcast. We will have a link to all her works in the show notes below. If you liked our video podcast, be sure to click like on YouTube or give it 5 stars on your podcast provider. Please subscribe to our channel to receive updates as we continue to interview maritime historians. You can follow NASO on Facebook or on Twitter at NASO_history. The best way to follow NASO is to become a member. As such, you receive our newsletter, our quarterly journal, The Northern Mariner, which we publish jointly with the Canadian Nautical Research Society. You can go to www.naso.org and click on membership to join. Until our next talk, keep sailing.